Hi everyone! In this video, we are going to discuss one of sorting algorithm, which is the insertion sort. The sorting mechanism where the sorted array is built having one item at a time. In this lesson, will show us how insertion sort works. I will show you the algorithm, pseudocode, and sample implementation with the actual output. We'll start on how this sorting algorithm really works. The first step involves the comparison of the element in question with its adjacent element. Second, and if at every comparison reveals that the element in question can be inserted at a particular position, then space is created for it by shifting the other elements one position to the right and inserting the element at the suitable position. On the third step, the second procedure is repeated until all the elements in the array is at their appropriate position. Let's have this example considering the given array, which we can clearly say that it is unsorted. On our first iteration, we compare the first element with its preceding, and the comparison shows that 16 is less than 24. Hence, we swap 16 and 24. On our second iteration, it begins with the second element with a value of 24, but was already swapped on for the correct position. So we move to the next element. Now the third element with a value of 30. Compare with the ones preceding it, which is 24. But since 30 is greater than 24, no swapping takes place. Also, 30 is greater than 16, so no swapping takes place, and 30 remains at its position. On the third iteration, we start with the fourth element with a value of 12 and compare it with its preceding elements. Since 12 is less than 30, we swap the two. The array shows that there are existing elements that we haven't yet compared with 12. Now the comparison is between 24 and 12. Since 12 is less than 24, we'll swap the two. The last comparison for the iteration is now between 16 and 12. The last iteration calls for the comparison of the last element with the value of 1 with all the preceding elements and make the appropriate swapping between the elements. Since 1 is less than 30, we swap the two. Then compare 1 to 24, and again we swap 24 and 1. Next, we compare 1 to 16, and another swap 1 and 16. The last comparison for the fourth iteration is to compare 1 and 12, and as a result, we swap the two. And here comes the sorted elements. So here is the pseudocode for the insertion sort. see the sample implementation of insertion sort in C++. I also put some comments to easily recognize the code and its function. So here is the continuation, the last part of the code, which is supposed to print or display the given array. And after a successful compilation of the code, we can run the program and let's see the output. As you can see, the output shows the sorted version of the given elements.